So now, a lot of electronic circuits use voltage dividers in some way or another, so it's good to know about them. So, in any case, if you have the supply voltage across series resistances, where they come together you get a fraction of the voltage. If half of the resistance headed to the positive supply from ground right there is the same as the resistance up there, then you're going to have an output voltage. That's about half the total voltage right there. And this is not for providing power because they got resistances. Any current you draw will lower that voltage. But instead, they're used to send a reference voltage. Other circuitry looks at that voltage and responds to it in some way. So now we have another simple example of a voltage divider right there. We're using equal value resistors. We got whatever voltage across it, we got across it. VCC usually means supply voltage. But in any case, whatever that voltage is, since we have three equal value resistors, and no matter what the voltage divider is, wherever the connection point is, you get a fraction of the total supply voltage. So these are equal value, makes the math easy. So at this point, in relationship to ground, we got 1/3 of the total resistance. Therefore, you'll have 1/3 of the voltage. That's just a signal voltage for other stuff to look at, or a reference voltage. Whereas over here, in relationship to ground, because that's usually how you measure electricity, we got 2/3 of the resistance over there. So there's less resistance up there. You'll have a higher voltage. So at this point, we'll have 2/3 voltage for a signal. So now, for examples, I like simple numbers. We got two equal value resistors here wired as a 2 resistor voltage divider. So we get half the voltage out. The value of the resistance doesn't matter because this is just a signal voltage. It's just meant to let other circuitry look at that voltage and respond to it in some way, a reference voltage. And so we could use 10K or 1K. Doesn't matter. Main takeaway is, this point, half the resistance goes to the positive supply, and then half the resistance goes to the negative supply. Usually you're looking at the voltage in relationship to the negative supply, but in any case, it's half of the total supply voltage. So we got 3 volts in relationship to this point down there. Also, if you want to look at it the other way, we got 3 volts there. This is 3 volts higher right there. But usually you look at that voltage in relationship to ground. So again, we're using 6 volts because it makes the math easy in this situation. 5 volts, the math gets a little bit more complicated. But main thing is, we got 3 equal value resistors right there. 1K, 10K, doesn't matter. This is just a signal voltage. That's why I put VS there, voltage signal. So signal voltage. So in any case, we have down here 1 resistor, so current's going to flow through there. We're going to build up 1/3 of the supply voltage, again, just for other circuitry to look at, not to draw power. So that voltage is in relationship to ground. We'll have 2 volts at that point, because we're using 6 total. Math is very easy. Whereas, going up here, we got twice the resistance on the lower side, less resistance here. That's going to pull up the voltage. So 2/3 of the resistance towards ground. So we got 2/3 of the supply voltage for our signal voltage. That's what VS is for, not supply voltage. So again, 4 volts for a signal for other circuitry. So now, if you're learning about voltage dividers and you're taking a course, you should already know about the current limiting resistor for the LEDs. 1000 ohm resistor, when you're protecting a red LED from 12 volts, the red LED drops 2 volts, putting 10 volts across the resistor. You get about 10 milliamps of current, which equates to about 0.1 watts because there's 10 volts across the resistor. You multiply them together. So, if you want more current without the resistor getting hotter, what you can just do is use 2 much lower value resistors right here. Their total resistance is about 540, so about half the resistance. But in case, each one of the resistors is getting about half of the voltage across them when it's setting the current through. So the amount of current is the total resistance, but each resistor right there, we have that. It's getting about as hot as a lone 1000 ohm resistor.